Hello, good evening, guys. My name is Yogendra Kumar. I'm a maths teacher at askIITians. Okay, today we are going to do polynomials chapter. Last lecture, it is lecture number 5, and I want to say it again that I hope you watched all my previous lectures before this lecture. I means 4 lectures which we have done on this chapter, and then you are coming to this chapter so that it will be like you will be understanding it more. And if you have attended those lectures, then this is going to be like very easy for you. You might be having idea about these all topics which we're going to discuss today already, right? I can tell you like this chapter is really important. Is it has good weightage in CBSE exam, your exam, right? Final exam, right? And this chapter is there with the same name next year also. So if you're doing this year very well, next year it is going to be, you can say like cakewalk for you, right? It is like really very easy chapter next year. If you have attended all these lectures and you have understood everything, right, then it is gonna be very easy, right? So I hope it makes sense to you, right? Okay, let's get started then. Okay, so what is the first thing we do? What are the things we have done already here? We have seen what is polynomial standard form. Then we have seen types of polynomials. We have seen how do we find out the value of polynomial? How do we find out the zeros of the polynomial? We have seen how we factorize. Okay, like different kind of polynomials. We have seen long division. We have seen remainder theorem. We have seen factor theorem, right? Splitting middle term method. So this, it is kind of some more factorization we are going to do for quadratic equations today. It is like more of practice of last class. Okay, like splitting middle term method, or like that we can say, right? So we are going to see quadratic polynomial and their factorization. Apart from that, I'm going to show you the cubic polynomials also. How can we factorize them, right? We can see that example also. And then roots and their graphical representation. This is what the main thing of this lecture, like this is the main topic of this lecture, right? So let's get started, right? Okay. So what is quadratic polynomial? A 2-degree polynomial, right? The degree of the polynomial has to be like highest exponent in the polynomial has to be 2. Then it is what quadratic polynomial. So I think you have seen this thing already. By the name, we say splitting middle term method, right? We have seen this because it is what 1. Let me write the x square. Writing the question. I want to factorize it, right? So what is the coefficient of x square here? 1. And what is the constant term here? Minus 30. I showed it that it is what? Negative, which is what? Obviously, right? It is what? Negative, and it is minus 30. So we look for the factors of 30, which are what? 6 and 5, 30 and 1. And it is like 15 and 2, right? We can have like this factors, but we need to choose the one which is whose difference we decide by this. Okay, negative, we decide whose difference is going to be 1, the middle term, right? So it is what? X square minus 5x minus or plus. No, it is going to be wrong here. Okay, you need to make which term is positive here. Yeah, this is what plus you need to write, and because we need to get minus x, so that's a minus 6 and plus this 30. Now we can take common. What we can take common? X plus 5 and minus 6 common here, x plus 5. So that's how we can factorize x plus 5 and x minus 6, right? These are the factors, right? You can, if you want to cross check, you can look back. Okay, like is it giving this expression or not? To factorize a quadratic polynomial into 2 linear factors, we can use the factor theorem, hidden trial method, to bring into the value of 0 or like that. Okay, so this is what? Splitting middle term method. Okay, that is what I want to name it, right? So we bring it to linear form, right? To linear form. So these are the examples. Let's practice more. I think we have seen this before also, but no problem. Now 8 is there. 8 and 1, it is going to be positive. So that's why 8 can be factorized as 2 into 4. So 2x plus 4x. Now it doesn't matter. You want to write 4x plus and then 2x, or 2x plus 4x. Now first 2, we can take x common. So x plus 2. Then last 2, what we can take? 4 common. So x plus 2. So what is it? X plus 4 and x plus 2, right? I hope you're understanding this. Now here it is what, 21, but negative, right? Negative means what, difference of two numbers. So I can write here 7x minus 3x. Why? Because 7 into 3 is what, 21, right? So minus 21. Now x plus 7 and x minus 3. You can see I skipped few steps, but I hope you understand this, right? Because I want to take the much more important thing. I want to explain you much more important thing, how we factorize cubic polynomials, right? Right? We need to see how we factorize cubic polynomials. So simple example I want to show here, factorization of cubic polynomial, right? Factorization of cubic polynomial. So what is the factorization of cubic polynomial? Like I want to, for example, I want to take this one, like I can write down x cube minus minus 9x. Let's say I'm taking this only, right? Now, how to factorize? I'm taking simple one only first. Okay. Now, what is the first factor you need to decide? You need to use trial and error method here, right? We need to put x equals to 0. We need to put x equals to 1. We need to put x equals to minus 1. X. We need to put x equals to 3 or something like that, which can give us what, something like which can make it 0, right? So I can see clearly p of 0 is giving me 0 here. So that is what my one of the factor, right? I can say like p of 0, and I can clearly see that p of x can be written as x common x square minus 9, right? X square is gone. Now further, it is what now, quadratic. So now all this previous rule, splitting middle term method, or like that direct factorization, we can see, right? Or identities. So here I can see x square minus 3 square, right? Let me use different color here. Yes, right? It is what this. Sorry, there was no square here. Yes. So what do we get here? X into x plus 3 and x minus 3. Again, the important identity which I told, I think I explained you before. A square minus b square can be written as a plus b into a minus b. So identities we have seen in last class, right? You have to remember all those, right? So I want to take another example of, let me take one more example of my what, cubic polynomial, right? So okay, 1 second, just give me 1 minute, guys. Yes, cubic polynomial example we need to take now, right? So I can take the example of any cubic polynomial. Let me take this one, which is what, we can take any example, but I want to take the one which will be like, I mean to say, like you can easily understand. First example, okay, we need to, let me take the example of cubic polynomial, which is what, like this, x cube minus 6x square plus 11x minus 6. Let me take this. This is my p of x. Now, how to do this, right? This is what the question now. How to do this? How to proceed? So first, we try to put x equals to 1. 0 will not make it 0, right? 0 is not going to give us. So this is what trial and error method, right? X equals to 1 if I put. So p of 1, I'm getting 1 cube minus 6 1 square plus 11 times 1 minus 6. Okay, wonderful. It is giving me 0. So we are lucky that by first putting 1 only, we got 0. If we are not getting 0, we need to try by minus 1. We need to try by 2. We need to try by minus 2 and all like that. Okay, so we are lucky here. We are getting 0, right? So what I can say now, what factor theorem says, as x equals to 1 is the 0 of this polynomial. So what we can say, x minus 1 is a factor of p of x, right? This polynomial, right? Very good. So if we got x minus 1 is one of the factor, right? So what we can say means this polynomial, given polynomial p of x can be written as x minus 1 into x square, right? X square, then okay, minus 5x and plus 6, right? Now how do we get this expression? You might be wondering. Okay, I wrote it directly, I know, but you might be wondering here how we got this, right? This is my p of x. So yes, it is what you get it by long division only. Means as we decided x minus 1 is the factor of p of x, so divide this polynomial by x minus 1 and you're going to get this, right? Now after this, x minus 1 into, we need to factorize this further, right? I hope you're understanding, right? This is what we need to factorize it further. So what we are going to factorize it here as splitting middle term method, right? Splitting middle term method. So what factors of 6 which can give us 5, right? So which are what 2 and 3. So it can be written x minus 2 and x minus 3, right? I hope you can do it because I showed it before only, right? So these are the factors we got for this cubic polynomial. So what is the method? Let me say it again. By the way, these are the factors. First we break down into two factors. We get two factors, then from those two factors we got three factors because it is cubic polynomial, right? It may not be possible all the time because sometimes this factor which we got quadratic expression, it is not factorizable all the time, right? Sometimes it is possible, but as of now you will get simple questions like this only, so you need to remember that we can factorize, right? Like this. That's why I chose the example like this, which we can get, right? So here first, you need to, by trial and error method, you need to decide the 0 of the polynomial. You need to put 1, you need to put 2, you need to put minus 1, you need to put minus 2. And you can put by 0 also, you can see clearly, right? One of the factor is what 0 only, right? So that's how we can decide. Then we decided that x minus 1 is a factor of polynomial, right? So we can do long division, right? I hope you're understanding long division. I showed it in the last class. You can go through that lecture and you can understand, right? I would suggest that you should understand that long division, right? Otherwise you can do it here. Okay, if you know, you just verify. I wrote it directly because I kind of like done here only, I did here only, right? Okay, this one long division kind of thing, right? So this is how we can decide by long division what is the remainder when this is what one of the factor. Then we get quadratic expression, so we can use their splitting middle term method to decide further two factors. So that's how we do it. I hope you understand this. So let's go to the next topic. These are the answers for first those two questions given. Okay, now this is really very important. What is the graphical representation? How do we understand the graphical representation of roots, roots and graphical interpretation of polynomials, right? So yes, so here we can see the roots of graphical representation interpretation for all other polynomials also, but we want to see, like, okay, let's understand for all linear, quadratic, cubic. Let's understand these all quadratic this graphical representation for all these polynomials. So I hope you have the idea about the linear one. If there is linear polynomial, linear polynomial is kind of this 2x plus 1. This is what example, okay, I can take. Now if I need to graph it, if I need to graph it, okay, so how do we graph any function or any Any function which is given like this, right? Okay, so we take x some value. We can take first a value. I suggest you that you take 0. So what is the y value we are getting? 1. Then I can take x equals to 1. Then what is the y value? Y is 3. Then I can take few negative values also, -1. When I take what I'm getting? Y is -1, right? Then you can take more values also, right? But I think this is sufficient, right? These values are okay. We can decide by these values only. So what is the graph we are going to get? So I have the point 0, 1, then 1, 3. You need to remember x coordinate and then y coordinate, abscissa and ordinate. This is the order we need to remember. -1, -1. So 0, 1, 0, 1 is going to be here. This is what my 0, 1 point. If I name it A, B, C. So this is my A point. Now 1, 3, 1, 3 is going to be here. I should make it more this side. And then this one, -1. This is my B point and this is my C point, right? So there is a straight line you can observe. This is what the straight line. That is the, you can say, beauty about the linear functions. Okay, linear polynomials, they always come straight line. Their graph is going to be straight line, right? Do you understand this? And there is a point which is cutting x-axis. There is a point which is cutting x-axis. Can you observe in the graph? You make the proper graph of it and then you observe this here. It is going to be the 0 where the polynomial cuts x-axis. That is going to be 0 of the polynomial. 0 of polynomial, very, very important point, is where graph cuts the x-axis, right? 0 is where the graph cuts the x-axis, right? This is what it is, right? You can remember. So this is what it is. Very, very important. It is that 0 is what where graph cuts the x-axis, right? This point is very important. Now let's come to directly. Okay, so you can remember linear polynomials graph is always a straight line. Okay, let's note down this point also. Graph of linear polynomials is always a straight line, right? This is what you need to remember. Now let's come to the graph of quadratic polynomials, right? That is what we need to understand. So just give me one moment. Okay, I want to add a page, blank page. Okay, I can say, so that I can explain you the graph here, right? Yes. Yeah. So graph of what I want to see? Graph of quadratic polynomial, right? And I want to have graph of cubic polynomial also, right? These two things I want to make you understand, right? So linear we have seen, right? Now we want to see the graph of quadratic polynomial. So quadratic polynomial is going to be, one second, p of x is equals to ax square plus bx plus c, right? This is what our quadratic polynomial. So its graph is going to be a concave up when a is greater than 0. This is what our x-axis, y-axis, and it is going to be concave down when a is less than 0, right? Now a is what? The leading coefficient. A is what? The leading coefficient. You have to remember it. So only the leading coefficient plays role in deciding whether it is concave up or concave down, means it is U shape or down U shape, right? Leading coefficient. So all the polynomials graph, all the quadratic graphs are going to be like this. Yes. All the polynomial graphs are like the, no. That's not correct. Quadratic graphs are going to be U shape up or U shape down, right? U shape or down U shape, right? This is what, and depending on A value, the coefficient, leading coefficient, right? Okay, if you want to observe an example, okay, example you want to take, let me take one example, right? What example I can take here? There is a polynomial, which is what, suppose it is, yes, x square and minus 4x minus 4, right? This is what I can have. So now what is this? Okay, like what is it going to show some like this graph, right? Okay, let's see. Now coefficient is what here? 1. So obviously it is positive, so that's why it is concave up U shape, right? Like this here. So you make table x and y values. Now what is y? We take this value only as y, right? Polynomial value ko we call it y here, right? This is what y is equals to this. We will write y is equals to x square minus 4x plus, not plus, minus, right? So we make this table. We make this table, which is going to give us the values. So let's decide at 0. When I put 0 here, it is giving me minus 4. When I'm putting here 1, okay, what is 1 giving here? If I put 1 here, it is what? Mm, yeah, okay. Can I take minus 5 here? It is okay, right? Okay. Yeah, I want to take, just let me make this small change here. Guys, I know I'm just taking example from my end, so that's why like it could be x minus 5 and x plus. I just want to take a proper example so that I can relate it to this. Okay, otherwise we can graph all the function, all the quadratic polynomials like that. Okay, but to take the proper example, okay, I think that will give you more clarity on this. So if I take yes, okay, let's take this. right? Now what it is, okay, what is the thing it is going to give? Okay, like something like yeah, if you factorize it, by the way, what are you going to get? Okay, if I put here 0, yes, it is giving me -5 here. If I put 1 here, if I put 1 here, what I'm going to get? 1 here, 1 here. So that is what, -4, right? 1 here, -4, so -8. Okay. Okay, now if I want to take here, let's take here -1. What about -1 here? -1 will give me -1 here and +1 here, so that will give me 0, right? What about 5? If I put x equals to 5, we need few values, right? We need few values to decide the graph, right? So that's what I just want to verify it. Okay, so if I take 5 here, 25 minus 25, so 5 is also giving 0, right? So let me graph this now. You need to understand this, that its graph is going to be something like this. At 5, it is what, 0, 5 comma 0. You can see 5 unit here and 0 unit on y-axis. -1, 0. That is also, so graph is going to be something like this. U shape, okay, like this. Why I made here 0, you can see, right? So that is the significance. There are zeros. If you factorize this polynomial, we are going to get x minus 5 and x plus 1, right? If you factorize this, you can take time and you factorize it. So that is the significance of zeros. Zeros are where the polynomial is cutting the x-axis. I hope you got the idea, and you verified this also when a is positive. So quadratic polynomial graph is going to be this shape, right? I think it's enough. You need to, you might be getting many doubts. Okay, you need to clarify with the teacher. You, like, we can have more understanding on it, but when you practice more questions, more doubts will come, right? But I think you got the basic idea. Quadratic graph is going to be like this: U shape, U up or U down, right? This shape we are going to get. There are values for this vertex we say here. We can find out those also, right? But that we study. Quadratic equation is a big, quadratic graph is like big topic to study, right? But as of now, you can have this basic knowledge, right? Let's come to cubic polynomial graph. So cubic polynomial graph, like you have seen, what you have seen previously, linear graph is cutting, x-axis once, quadratic graph is cutting x-axis twice, and cubic graph is going to cut x-axis how many times? 3 times, right? 3 times week it cuts, but it may be cutting once also. This is also possible, right? But ideally what it should be, if it is factorizable into 3 factors, it should be cutting at 3 points, right? So this is what the idea, you need to remember it like this. Now if I take the example which I did previously, and I want to show you the graph of that, right? I want to take this example, which is what, let me rewrite it here and let me show it to you. So what will be the cubic polynomial is what? X cube minus 6x square plus 11x minus 6, right? This is my cubic polynomial. So first we write y is equals to x cube minus 6x square plus 11x minus 6. Now you know that how we factorize it, right? You can remember, you can recall the factorizable form of this, right? X minus 1 into x minus 2 into x minus 3, right? This is what factorized form of this. So its graph is going to be, zeros are what, 1, 2 and 3. So you need to see here, 1 minute. Its graph is going to be like this. Okay, it has to be smooth curve, not cornered one. So this is what it is: 1, 2, 3. Now why one end is up, why one end is down, why both ends are not down, that depends on the, you can see, like you can observe that thing by putting minus very big value here, minus 1000. If you put here, it is going to give you negative value. Like it is like almost minus infinite here and positive infinite here, right? So that way, if you see again, if leading coefficient is what, like this, it will be like this. Otherwise though, it is going to be this shape for a less than 0, right? Like that it is. So I hope you got the idea. We have like this, okay, one leading coefficient like this or like this, okay. Again, like you put minus infinity, and same reason is there also, right? If you put minus infinity, it is going to be negative, and if you put here positive infinity, it is going to be positive value, because a is what, positive here, right? So that's how we decide. So cubic polynomial is what, this type of graph, right? So I hope you got the idea. These are the graphs, right? You need to remember. Now let's try this question. The graph of, you can pause the recording and you can try this question. It is really good question. Okay. The graph of y is equals to p, x is equals, polynomial x is given below for some polynomial p of x. Find the number of zeros of p of x in each case. So here it is not cutting the x-axis. So number of zeros is equals to 0. No 0, right? Because there is no number of zeros, I said, not zero is the solution. Okay, number of zeros here. Number of zeros are what? How many times it is cutting x-axis? Once. So 1. Don't look at the shape. 0 is what? 1, right here. Oh, now here 3. Right? I hope you got the idea. How many times a graph is cutting the x-axis, that is what deciding factor for the number of zeros of the polynomial. Okay, 0, 1, and no, it is 3 here. You can see clearly thrice, right? Okay, you can see clearly thrice it is cutting, right? That's also, this is what we have the solution. Now you can see these all questions. We can factorize it again. Okay, like let me show you. X square plus 12x and plus x plus 4. We can pair up like this. So it is giving us x plus 4 and 3x common here. So 3x plus 1, right? This is what we have here, right? You got the idea. Now graph of this is given below. So again zeros. 2 here in first case, what? 2 here, 1, 2, 3, 4. So 4 here. Here you can see here 1, 2. It is not cutting twice. It is cutting just once. 2, 3. So 3, 2, 4, 3, right? That's all. So I hope you enjoyed. You got the idea about the graph, how we get the number of zeros, right? This is really important session. Okay, you need to remember these graphs. You can study for more graphs also further. You need to look at the examples. Enough examples are given in the module. You need to practice more, right, to understand it clearly. Okay, I hope you enjoyed it. Thank you very much for your time. Thank you. Bye bye.